Good evening, Cardinals. It's me, Mr. Ernst, and today we're going to be learning how to solve an inequality. So let's start off by reviewing what is an inequality in the first place. So we've been working quite a bit with equations. In other words, two things that are perfectly equal to each other, such as 7 being equal to, whoa, that's way too big, 7 being equal to 7. However, if I have 5 and 7, I can't use an equal sign because they are two numbers that are not equal. Instead, I have to use an inequality. Inequalities are greater than, less than, greater than or equal to, and less than or equal to. Anyways, because 7 is bigger, we want the open side of my arrow to face that way. And the reason for that, this whole sign, the way that you can think about it, you can either think of it like the crocodile mouth always goes towards the hungry side, or this opening is much larger than this very, very small closed opening. So we always want to put the larger opening towards the larger number and the smaller opening towards the smaller number. Just a quick little review of that. This is an equation. When they're not equal, we have to use an inequality. So let's take a look at what this looks like on a regular old problem. First problem we're going to look at is going to be x plus 3 is equal to 5. So this is just an equation because there's an equal sign here. So we're just going to solve this. I need to isolate x. To do that, I'm going to subtract 3 from both sides because that's going to cause this to cancel out. That leaves me with just x is equal to 5 minus 3 gives me 2. My solution is x is equal to 2. Now let's look at what the inequality would look like. Same type of thing, x plus 3 is greater than 5. Same type of thing. To get rid of this x, or 3, I'm going to subtract 3 from both sides. These cancel out, leaving me with just x is greater than, 5 minus 3 is still 2. I want you to notice these two answers look, and we found these answers by doing the exact same thing. The only difference is the sign between them. In the first equation, x was equal to 2. In the second inequality, it is x is greater than 2. But we solved it the exact same way, which is pretty neat. So let's take a look at another example. Once again, we're going to make this one look a little bit more fancy. This one's going to be 3x minus 4 is greater than 8. Once again, I'm trying to isolate this x variable, so my first step is going to be to add 4 to both sides. That's going to cause these two to cancel out. 3x is just going to come straight down, so I'm going to have 3x. That comes straight down. Is still greater than, and then we have 8 plus 4, which gives me 12. Once I'm at this point, I have 3 multiplied by x. The opposite of multiplying by 3 is to divide by 3. Divide both sides by 3. That's going to cause these 3's to cancel each other out, leaving me with just the x. So I'm going to have x is greater than 12 divided by 3 gives me 4. And there's my answer. X is greater than 4. Again, this would have, if this was an equal sign, it would have simply looked like x is equal to 4 at the very end. But since we have a greater than sign, it's greater than. Now, there is one special exception to this when it comes to solving an inequality that equations don't have to worry about. So inequalities have one weird thing that doctors hate. Okay. Same equation as before, 3x minus 4. I'm sorry, same inequality. Same as before, this is 3x minus 4 is still greater than 8. Cool? The one change I'm going to make this time around is I'm going to make this a negative 3x. Let's see how this changes everything. As I go through, same steps as before. I'm adding 4 to both sides to cancel out that 4. These two cancel out. Leaving me with, I have negative 3x is greater than 8 plus 4 is still 12. Notice that this point and this point are relatively the same, except I have a negative 3. Now's where we're going to be running into something kind of silly here. With inequalities, when you have a negative number that you are either multiplying or dividing by, it's going to cause you to flip the sign. And I'll explain why in a second. So for right now, I'm just asking you to trust me. Negative 3 multiplied by x. Divide this side by negative 3. And divide this side by negative 3. Once again, we do this because it's going to cancel these out, leaving me just x. And on my right-hand side, I have 12 divided by negative 3, which gives me negative 4. But if you're multiplying or dividing by a negative number, you have to flip the sign, and it has to be a negative number. I'll say by a negative. That's about as accurate as I'm going to get. By a negative. So because I had to divide by 3 here and divide by 3 here, get a better color for that. Divide by 3 here and divide by 3 here, this sign is not going to be the same down here. It's not going to be greater than still. It's going to flip. And it's going to instead be less than. So we have x is less than negative 4. Cool? And now I'm going to show you why that happens. So remember, if you're multiplying or dividing by a negative number, you have to flip the sign. If it's a positive number, the sign stays the same. If it's negative, it has to flip. I'll show you why we do that. There we go. Let's look at a number line. That's a pretty good number line right there. 0, 0, 0. There we go. That's a pretty looking 0. I'm going to say 2 is right about here. And I'm then going to say 4 is right about here. Looking at this, we know between 2 and 4, 4 is greater than 2. That's a true statement. Cool? So we have our greater than sign. 2 is greater than, or 2 is less than 4. Sorry, I think I said greater than. I read it backwards. 2 is less than 4. When you multiply something by a negative number, so let's say I'm going to multiply this one by negative 1 and this one by negative 1. Cool? So I'm going to multiply both of those numbers by negative 1. So that would turn this into negative, a negative 2, and it would turn this into a negative 4. So I'm multiplying both of them by a negative number, okay? When I do that, and if I was to rewrite these things over on my number line, so negative 2 is going to be right here, and negative 4 is going to be right here. The problem is this less than symbol is no longer correct, because if I write these things out, I have negative 4 and I have negative 2. This value is now greater than that. Negative 4 is less than negative 2. So when we multiplied by the negative 1, the sign has to flip. This actually comes a lot, you can kind of think of this in terms of like a reflection. So if you think of this and this side is being reflected over onto this side, it causes the sign to flip when you multiply by a negative number. Because what was less than over here, 2 was less than originally, but when we flip over to this side, now it's the negative 4 that's less than. So it causes the sign to flip backwards. Cool? That is why we have to flip that sign. Last thing I wanted to do, one more question for you guys as just a last example. we have negative 4 multiplied by x minus 3, close parenthesis, is greater than or equal to 8. This little or equal to sign, nothing's changed. Everything's still exactly the same. To solve this, I have to start off by distributing, multiplying the negative 4 times the 3, and the negative 4 multiplied by the minus 3. Negative 4 times the x is negative 4x. Negative 4 times the minus 3 is going to give me positive 12, is greater than or equal to 8. From this point, minus 12 from both sides, which will give me, these guys will cancel out, leaving me with just minus 4x, is greater than or equal to 8 minus 12 gives me negative 4. At this point, I have to divide this side by negative 4, divide this side by negative 4. So on my left, these two cancel out, leaving me with just x. X. I have on this side negative 4 divided by negative 4 gives me 1. And then because I had to divide by a negative number here and here, because I had to divide both sides by a negative number, this sign needs to flip. So it's no longer greater than, it's now going to be less than. So x is less than or equal to 1. And that is how we are going to be solving our inequalities. So good luck on your assignment, and yeah, have a good rest of your night.